All right. Hey guys, sorry I can't be here, but I figured this video is the next best thing. So hopefully you've taken a look at the homework and you've noted any questions that you're having. I did want to make sure that we kind of touched on some of these ideas again, and so that's what this first video will be. So while in the John Hancock building in Boston, you think it'd be fun to drop a tennis ball out of the window on the 7th floor, to about 75 feet above the ground. Not a good idea, by the way. After you're arrested by the police, you have some time in your jail cell to consider the following questions, because clearly you'll be thinking about calculus. If your position function is given here, where t is the number of seconds, what is the velocity at 2 seconds? All right, so to be able to do that, the first thing we need to know is actually what is the velocity function. Recall that if you take the derivative of position, you do get velocity, and this is a function we know how to take the derivative of, right? In this case, it would just be negative 32t based on using the power rule, okay, from this equation. And so then what is v of 2? Well, v of 2 would be negative 32 times 2, which is negative 64. Of course, we're thinking about labels, and in this case, it would be feet per second. Okay. What is the acceleration? Well, before we can do that, remember that if you want the acceleration, that's the derivative of velocity. So if I take the derivative of the function we already found, right, that will give me acceleration, which would be negative 32. Why is this constant again? Okay. This is constant because it represents gravity.
Kathy Brown, please go to room A327. Kathy Brown, please go to room A327.
Sorry about that interruption. Okay, so because it represents gravity. So if I'm looking at 1 second, it's negative 32, again with labels, feet per second squared. If I'm looking at 2 seconds, it's negative 32 feet per second squared. And in fact, this will be constant the entire time, again, because it represents gravity on the ball. Okay. All right, let's keep it moving here. Okay, what is the velocity of the ball at 3 seconds? Okay, let's take a look. So all I need to do is, actually, I'm going to come back to this question. Let's do the when will the tennis ball hit the ground. This is a when question, right? So I know that my answer is going to be seconds. And hitting the ground, okay, if I'm thinking about which equation to use, hitting the ground is a place to be. And so hitting the ground means when the position equals 0. Okay, and I have a position equation, and I can easily solve this for 0. Now, you could factor, because there's a t in only one spot right here, I can go ahead and just solve algebraically. If I subtract 75 from both sides, I get that, okay? And then if you divide both sides by negative 16, I'm back to being positive. And so if I do t squared equals, and it's like approximately 4.6875. If I take the square root of both sides, right, I can get an answer of, and remember when you introduce the square root, there actually is 2 answers, so t equals plus or minus 2.17. Of course, in this particular case, the practical domain, right, would say that it's just the positive one, right? There is no such thing as negative time. So it hits the ground at 2.17 seconds. All right, so if I go back up to this one and I say, what's the velocity at 3 seconds? Well, I'm plugging 3, right, into this equation, my velocity equation, and I get negative 96 feet per second. The problem is that I know the ball hits the ground at 2.17 seconds, so asking about velocity at 3 doesn't really make sense. And one way to show that is, what is the position at 3 seconds? So if I went back to my position equation and actually plugged in 3, I actually get a negative 69 feet, which would mean that it's underground. So unless it is falling into a big hole, which I didn't tell you, right, this doesn't make sense. So the tennis ball is in the air from 0 seconds to 2.17 seconds, and asking about a time after that doesn't make a lot of sense. Okay. All right, when is it speeding up? For it to be speeding up, I need velocity and acceleration to have the same sign. Okay. All right, so I am looking for, let's think about acceleration first. I know my acceleration function is negative 32, right, which is always negative. So basically, I really need to think about when will my velocity function be negative so that they will have the same sign. Well, if you think about it, right, here's my velocity function. What kind of time values am I accepting? Okay, I'm accepting time values that are positive because there's no such thing as negative time. So if the t value is going to be positive, then this will always be negative as well. Because we are only using positive t values. So as soon as t equals 0 has happened, then I know velocity will be positive. So when is it actually speeding up? Or sorry, velocity will be negative. When is it actually speeding up? Okay, so anytime after 0 seconds, right, because at 0 seconds it wouldn't be, right, they wouldn't have the same sign, until 2.17 seconds, because we don't need to talk about any times after that.